Hello everybody, welcome back to MrMiers Math Channel. Today in Chapter 9 where we talk about rational functions, we're going to go over Section 9.3, simplifying and multiplying rational expressions. Alright, so let's get into it. Alright, first let's talk about what a rational expression is. A fraction whose numerator and denominator are non-zero polynomials is a rational expression. So neither one of them can be zero. Rational expression is in simplest form when its numerator and denominator have no common factors other than positive and negative 1. Right? An example of this would be shown below. Let's let A, B, C be non-zero real numbers or variable expressions. And let's say we're starting with AC over BC. Well, AC is just A times C, and BC is just B times C. All right, and then we see that we have C over C here, which is unnecessary. Anything divided by itself is 1, so we would cancel out those common factors, and it would leave us with A over B. All right, so that C over C is unnecessary, and that's why we would want to simplify. All right, so we're just dividing out the common factor of C. All right, so let's talk about some examples. And some of these examples, some of these are already going to be simplified, and some of these we're going to have to simplify by canceling out common factors. All right, so one way to cancel out common factors is just to rewrite the numerator and denominator by factoring it out. All right, so we're just going to separate 8x and 12x squared, and we're just going to take a look at what are the common factors that these things have in common. So 8 and 12. All right, when I think of 8 and 12, those would both have common factors of 4. And then if I look at x and x squared, this obviously is x to the first power, so there's 1x multiplying in the numerator, 2x's multiplying in the denominator. The common factor there would just be x. That's the maximum amount that we can take out of both. 8x is just 4x times 2, and 12x squared is just 4x times 3x. Now 4x divided by 4x is 1, so we cancel out that common factor, and that just leaves us with 2 over 3x. All right, same thing as in B. In B, just going to take a look at the 4 and the 6. The greatest common factor there would be 2. And then between the n to the 5th and n to the 5th, obviously that's the same, so we could take out an n to the 5th. 4n to the 5th is 2n to the 5th times 2, and 6n to the 5th is 2n to the 5th times 3. And now we cancel out the common factor, and that just leaves us with 2/3. All right, if we take a look at C, 5 and 2, if we think about the factors of 5, that's just 1 and 5. And if we think about the factors of 2, that's just 1 and 2. And then there's only an m in the denominator, no m in the numerator. All right, so the common factor there is 1, so that means this is already simplified. All right, if the only common factor is 1 or negative 1, then this thing is already simplified. All right, if we take a look at D, between 10 and 25, we have common factors of 5, so I'm just going to write that negative, and then we have 5 in the numerator and denominator. And then n squared and n to the 5th, the most that we could take out of both of these would be 2 of those n's, so that's n squared in the numerator and denominator. 10n squared is just 5n squared times 2, and then 25n to the 5th is just 5n squared times 5n to the 3rd. Cancel out those common factors, and that leaves us with negative 2 on 5n cubed. Awesome sauce. There's a lot of examples built into this section. Some of them are very necessary, and then some are not very necessary. We'll try to skip as many as we can, the ones that are unnecessary. All right, so let's take a look at the next 4 examples. So E is going to be one that we're going to skip. And then we're going to just move right on to F. I'll just skip there. For F, this one is probably one of the most commonly missed questions here. When asked to simplify this expression, I'll see a lot of people just write 5. All right, and 5 is not the answer. What they're trying to do is cancel out these x's, but one thing they may not realize is that x plus 5 is the factor in the numerator. Okay, so it would take an x plus 5 in the denominator to cancel out this x plus 5. These things are bundled together. All right, just like it would take just an x, a lonely old x, in the numerator to cancel out this x in the denominator. All right, the reason why we can't like cross out the x's is we could just plug in some numbers and figure out, why that's the case. So let's plug in 1 for x. We'd have 1 plus 5 over 1, which is 6 over 1, which is 6. And obviously we can see that 6 is not the same as 5. So that's why we can't do it. It would give us different values every single time. All right, so this is already simplified, so I'll write simplified. And we'll move on to G. All right, just like we just talked about, the x and the x plus 1, those are not the same factors, and we can only cancel out those common factors. All right, so we can't cross out an x and the x plus 1. All right, so now we just take a look at the 9 and the 12. And one way to simply and easily do this would be canceling out the common factors right on the problem here. All right, so the common factor between 9 and 12 is 3, so if we take out a 3 here, we'd have a 3 left over. If we take out a 3, we'd have a 4 left over. So that leaves us with 3x on 4 times the quantity x plus 1. And then H is another one of those most missed questions. This would be most missed because maybe we wouldn't cancel anything out. There's a hidden common factor here that we wouldn't see if we don't factor the numerator. So we've got to factor every single thing that we can to reveal those common factors that we have in these expressions. So I'm going to factor from the numerator, and we can factor 2 out. All right, 2 would be a common factor between 2a and 4. So if we factor a 2 out, that would leave us with 2 times the quantity a plus 2. And that helps us because it shows us that, hey, this is a factor, and now we've got 2 common factors. All right, so that would just be 2. All right, moving on here. Now we're talking about multiplying rational expressions. All right, so we're going to do some simplifying. We're also going to do some multiplying. Basically, to multiply, we multiply the numerators and multiply the denominators. Or in other words, we just multiply straight across. It's one fraction times another fraction. Okay, and we multiply the numerators and denominators. And we're going to see like 2 primary methods for solving or simplifying these problems. Now, in the first one, it says multiply, then simplify your results. Okay, so I'm just going to go ahead and do that. And we're going to see why this is not the most efficient method. So multiply, and we'll get 12 over 20p. And now we got to simplify. So now we got to think, oh, what is the common factor between the numerator and the denominator? Between 12 and 20, well, guess what? That was just our 4. So 12 is 4 times 3. 20p is 4 times 5p. We could have canceled out those common factors of 4 right away, and that would have just saved us some steps. So sometimes it is going to be beneficial to multiply, but most cases we want to cancel out common factors if we have them or if we see them first, and then multiply it after that if necessary. All right, so we're going to move on. We're going to do a bunch of examples here. And like I said before, we're going to skip some as we go. Let's start with part A. All right, so one thing that we could do is multiply right away. So I'm just going to go ahead for this example and multiply right away. So multiply the numerators first, and we get 36x cubed on 24x to the 6th. And now from here, what we could do is cancel out the common factors. So 36 and 24, the greatest common factor there is 12. All right, x cubed and x to the 6th, the greatest common factor there is x to the cube, x cubed. Now 36x cubed is just 12x cubed times 3. 24x to the 6 is just 12x cubed times 2x cubed. All right, so we cancel out that common factor, and what we have left over is 3 on 2x cubed. All right, so that's a lot of steps, okay, multiplying, simplifying, crossing out those common factors, and then finally writing our answer. That's not the only method, though. The other method, remember, is we could just write down on the problem us crossing out those common factors and writing down what we have left over. So B is a good example of it not being necessary to multiply right away. So 7 and 8, there's no common factors there. 3 and 10, no common factors. And also, remember, all of this on top is just going to be 1 anyway, so we want to look at all these common factors to cancel out. The only thing that I can see is n to the first and n to the second. There's an n in the numerator and denominator. Let's cancel out one of those n's, and that would leave us just with n in the denominator. And now let's multiply straight across, and we get 21 over 80n. All right, C is a good example about us crossing it out right away. 3 over 3, that cancels out. 10 over 4, the greatest common factor there is 2. So once we get rid of that factor of 2, we'd have 5 and 2 left over. And then we can just multiply straight across here, and we get 5 on 2n. Now let's take a look at D. Okay, this is a good example as to canceling out common factors where they're diagonal. Okay, so 6 over 8 can cancel out those common factors of 2 there. And we'd have 3 and 4 left over. And then we can see there's another common factor here, 3 and 3. That cancels out. And we get 5 over 4v. All right, now we're going to get into a little bit more examples that have polynomials, or multiple polynomials, and multiple factors. If we take a look at E, like I said before, to get rid of a p plus 2, it would take another p plus 2 in the denominator. And we have that, so we can cancel those out. And then to get rid of a p minus 3, it takes a p minus 3 in the denominator, and we have that. And that just leaves us with 7 on 8p squared. If we take a look at F, it's the same thing. To get rid of k minus 2, we need a k minus 2. So also the k minus 10s will cancel out, and we're just going to have 9 on 10k. Pretty simple there. Might look a little bit more intimidating, but it's not too bad. All right, let's move on. In part G, we have r plus 3 squared in the denominator, and we have an r plus 3 there, so that cancels one of them out, and then this r plus 3 cancels out the other r plus 3. Now the reason why I also want to go over G is because even after that, this is still most commonly missed question. All right, 6 over r plus 8. Remember, we can't cancel out any common factors here because r plus 8 itself is a factor. Okay, it would take another r plus 8 in the numerator to cancel that out. And a lot of people that I see will want to cancel out, simplify that 6/8. But we really don't have 6/8. It's 6 on r plus 8. Now we're going to have to do some factoring here in the next example. So factor as much as we possibly can. So starting with that denominator in that first fraction, we can factor a 4, and that would be 4 times x minus 3. And then we can factor the numerator in the second fraction. Right? X squared minus 9 is just x plus 3 times x minus 3. Now we could cross some common factors out, x minus 3 and x minus 3, x, and that would leave us with 3 times the quantity x plus 3, all on 4. skip that next one, and then we're going to go right to J. So we're going to simplify this trinomial. So factor that trinomial, and remember we have a bunch of different methods by which we can factor. I'm just going to go with the tried and true method of basically guess and check. M squared to get that is m times m, and then 15. The last two terms in each one of these factors have to multiply to be 15, but also the outer and inner parts of FOIL have to add up to be negative 8m. All right, the only way that's going to happen is if one of them is negative 5, the other is negative 3. And then by factoring, that reveals a common factor, and we can simplify, and this is just m minus 5. All right. In K, we got to simplify that denominator first. So factor out that greatest common factor, and that greatest common factor would be 4x. And that leaves 2x plus 1 remaining. There is still 1 there. Remember, when we take out a 4x, that doesn't leave just nothing, because 4x divided by 4x is 1. And now in the numerator, I'm just going to factor out a 4x also. Cancel out that common factor. So we have 4 on 2x plus 1. All right, let's skip past L here. Let's move on to M and N. All right, these are the last two here. So for M, we can simplify, simplify that second fraction. So we have 1 over b minus 2. And then if we simplify b squared minus 10b plus 24, that would be b minus 4 times b minus 6. And then if we factor 4b squared minus 24b, we could factor out a 4b there. And that would be 4b times the quantity b minus 6. The b minus 6's cancel out, so we have b minus 4 on 4b times the quantity b minus 2. Now last one is n. Let's simplify as much as we possibly can. That would be the denominator in the first fraction and the numerator and denominator in the second fraction. All right, so the denominator in the first, that would simplify to be x plus 9 times x minus 4. The numerator in the second fraction, that would just be x plus 3 times x plus 1. And then the denominator in the second fraction, we could factor a 3 out, and that would be 3 times the quantity x plus 1. So we see x plus 1's cancel out, we see some 3's cancel out, and we would just have x plus 3 on the quantity x plus 9 times the quantity x minus 4. And we could just leave it like that. All right, folks, if you enjoyed that or if you thought that was helpful, please like, subscribe, and share. Thank you, and have a great day.